It's us again. Look at that.
I think the super awkward introduction is just a part of the show format now.
Write a better introduction that I will not read, and we can try it out.
It's better to be awkward and not try than awkward and do our best, I think.
Yeah, exactly. That was awkward.
Leading into who we are. So welcome to You Choose Your Own Adventure style show through the CNCF landscape. This is chapter 5 and episode 2, and we're talking about policies and state synchronization. But this episode is special.
Yeah, okay. Why?
Because we have no guests and you're not choosing anything.
We're living the dream. I never liked people. Kind of like, if I must be surrounded by them, let it be one instead of more. I think that's wonderful. I'm happy for me.
Why do we have no guests besides the fact that you scared them all off?
Is there a different? I thought finally kind of she fulfills one of my wishes. Okay, there is another reason. Okay, go for it then. Yeah.
So we're going through the steps to build an internal developer platform. And 2 of the system design choices that are important parts of building a platform include state synchronization and policy. But we've already done episodes for both GitOps and admission controller policy in past seasons. GitOps happened during chapter 2 and policy happened during the security chapter 3. So since we've already done it, we're going to recap what you already chose. And we're going to talk about these things in the context of an internal developer platform.
Yeah, so it will be slightly different.
So
just in case people leave, kind of like I already heard it. You did. But we're going to change the wording so that it looks like you didn't. No worries.
Wait, this one is you chose, not you choose.
Okay.
Yeah. I've been thinking I had that ready to go for a week. I thought of saying that a week ago. So that was a highlight for me. Hello to everyone in the chat. Thanks for being here, friends. Let's get started by talking about last week. So last week's episode was about API and state management. Yeah, what did we call it?
Yes.
Yeah.
Yeah, state management, API and state management, yeah.
And
different subjects covered by the same tool.
Yes.
So
tools. Why do we even need an API layer as part of our platform?
So that people or tools people use can talk to our platform. It's like a phone line.
So why is that better than just like calling Terraform APIs directly or calling, yeah.
Because it's been like, 30 years or 40 since we discovered HTTP APIs. And it's been probably like 20 years since AWS discovered that that's the only way how to serve a platform. And it's been slightly shorter period of time since every single vendor on this planet accepted that we should be using HTTP APIs to talk to their platform. And now we're coming to the realization that actually, you know what, maybe that's not such a bad idea for us either.
I appreciate that answer, but also...
here it comes, but.
Just because everyone else is doing it isn't a good answer.
Okay.
Give me another one.
Cool, because giving people files that are sent and transformed into something else is silly. Because it is easier for other tooling to integrate to do whatever they need to do through APIs, because it's much easier for them to communicate through HTTP APIs than sending files around. Because it has discoverability, so that those tools can discover what can be done in your platform instead of having hard-coded stuff that cannot be discovered.
Love it.
Okay, that.
Because you can put more than one interface on an API?
I mean, you can do it with the files as well. It's just so tedious, right? Because So here's a good example, like kube control. CLI, everybody uses it, right? Now, kube control has no idea what is in your cluster. No idea, right? It has no idea what you can and you cannot do. It has no, let's say that you installed in your cluster CMPG, Postgres database. It does not know that there is a CMPG over there, but it knows how to talk to API. It knows how to discover, okay, so there is something called like this and there isn't something called like that. So I cannot do this and I can't do that, right? The only thing kube control has baked in are the generic rules. Hey, everything in that API can be retrieved, like get operation. I can put something over there or suggest to put something over there. And I can request deletion of that something, right? So I can get information, I can put information, and I can instruct it to delete stuff. I do not know what stuff is. And yet, kube control works when you add new stuff to your Kubernetes. Kube control works without you changing the source code of kube control and compiling it again.
Yeah. Okay, now I'm convinced. APIs are the way. So
okay, good.
Now, something else we went over last episode that everyone could agree about was that Kubernetes, it's good to build your platform on Kubernetes. What do you say about that?
Yeah. First of all, everybody's doing it. I intentionally start with the favorite answer. But everybody's doing it is very important here because basically most of software vendors on this planet agreed that will be the base platform, not the usable platform, but base on top of which they can run their stuff, right? So basically everything can run there. And everything works with everything else because everybody is forced to follow certain rules, right? So everything can be run there, everything works with everything else, everything is integrated with everything else. And it is extensible. And there is a mechanism how to easily extend Kubernetes API, right? So not only that you have the freedom you didn't have, or ease, not freedom, ease to combine and use anything you want. You already have significant part of the work to create your own APIs done for you, right? Because Kubernetes has a baked-in mechanism. How do you extend API? Well, there is something called CRD. This is how you create CRD. It's just pure YAML. Go for it, right? It can be anything you want, as long as you follow the rules. Not many.
And when you say anything you want, you mean like it could be WASM, it can be VMs, it can be cloud infrastructure that's completely outside of Kubernetes.
That comes later, right? First thing is how do you create the API endpoints? The other thing is what is happening when somebody creates a resource based on that endpoint, right? Now, API itself, when you extend it, is going to do nothing. Zix, nothing, nine, nix, right? Ochi. That was Greek. So it's going to do nothing. It's just going to extend the API and say, from now on, you just created something called Whitney. And this is the spec of Whitney. And from now on, people can request to create, delete, update Whitney and retrieve Whitney as well. Now, if that's all you did, nothing will be happening. The only thing that API will do is that it will validate that Whitney resource you're trying to create complies with the schema that you defined. If it complies, it will do two things. I mean, more than two, but two important things. First, actually, there are more, but we're getting to that later. The first thing is it will announce to the world, and when I say world in this context, I mean Kubernetes itself, hey, somebody created Whitney. And then it forgets about it. It doesn't care about it, right? I said that somebody created this thing, and I'm going to store it in my internal database, which is etcd.
Yep.
And there we go.
That's all that
announcement was made. Nobody ever read it. It's like putting an ad in a newspaper, that was never that was printed but never shipped to anybody. Right? You have your ad. It's there.
Okay. You said there were two things. Yeah.
And then we come that's two things. Announce that something was done, create an event to be more precise, and store it in an internal database.
Okay.
It's a system of record of sorts. Now, besides creating APIs, 0 or 1 or more of the processes inside Kubernetes can listen for those events. But that's not mandatory. Nothing might be listening as nothing is listening if all you did was extend API. Now, if you have a process that is listening for those events, we call it controllers in Kubernetes, then some controller might say, okay, you know what? When I'm listening for events that are related to Whitney. So when somebody does something with that resource, I'm going to do something with it, right? Whatever that something is. And that's when the action starts happening. That can be, I'm going to create a pod. Or, I'm going to create a deployment. I'm going to create a database in AWS. There is no limit. There is no prescription what that controller will do. That's up to the designer of that controller to choose and do, right? So you have events, and that's what API does. And then you have entities listening for those events and doing something. And that applies not only when you extend Kubernetes. That's how even the endpoints or CRDs or RDs and controllers that are baked in Kubernetes are behaving exactly the same way.
So what does this have to do with Kubernetes being a good platform to build your platforms on? A good tool to build your internal developer platform with?
Okay, so let's start with saying that on a very high level, your platform should have API. You gave up fighting me on that one, right? And it should have some services behind that API doing something, whatever that something is, right? And we have a widely adopted, unwritten standard, whatever annoying word you want to use, that does just that, Kubernetes. Right? So it's standard of sorts, everybody's using it, and significant part of the work is already done for you, right? How are you going to extend API? Well, you don't need to think much about it. This is how you do it, right? How are we going to run those services that do something when somebody does something with API? Well, there is a mechanism for that as well. It's called controllers, right? And so on and so forth. So yeah, you can do it without Kubernetes, but then you're missing on the ecosystem. That's one. Like we're going to speak about Kyverno and argocd today. I dare you to run it without Kubernetes, right? And the work that you yourself would need to do, creating those APIs and services and what's not, significant part of it is done. So yeah, you can go without it. If you're a masochist, why not?
So then last episode was not just about APIs, but also state management. So
that's
that's the storing it in etcd in a database.
So that's what controllers do, right? Controllers react, assuming that we accepted Kubernetes as a base on top of which we build platforms. The reactions to those invocations of the API, they're done by controllers. And independently whether we're talking about Kubernetes or no, we have two types of tasks, let's call it, right? We manage the state of something, like, hey, the application, right? It should be running. And this is how it should look like, and so on and so forth. That's state management, right? And then we have one-shot actions, like I want to build an image. It's not something that I want to do over and over again and ensure that image is built and so on and so forth. No, I want to do it once. I'm not going to manage any state.
Declaring act like your desired state in one.
Yeah, it's similar to basically you executing shell commands, right? I want to execute this shell command, and that shell command will do this and that, whatever that is. And when it's finished, I'm never going to execute it again unless something changes, typically in my source code, right? So you're going to run a test once for every commit, not continuously, right?
And we'll be talking about that next week. and talking about tools that do that next week.
Yes. Now we know what's the subject of next week. That's great.
Yeah. You said from the bottom of your heart. So what I want to talk about now, if you feel like you have it covered in terms of why we did API and state management. Like,
look, Whitney, I had it covered after 10 seconds, and then you forced me to talk more about it.
Everybody does it. So. That's why you should do it. The end.
Yeah.
What I want to talk about now are the 3 tools that we got presentations from, which was Kubevela, Cradix, and Crossplane, and what those 3 tools have to do with each other and how they're different from each other.
This is going to be hard because I work with Crossplane, so I'm biased. That's why I'm trying to stay away. Okay, let's do it this way. You tell the difference, but before you do, let me just give you a high-level overview of what they really do. And what they do is what we just spoke about. They create API and they extend Kubernetes with 1 or more API endpoints, depending on the tool, right? They allow you to create custom resources based on those CRDs, on those endpoints. So that's the API part. And then, depending on the tool, they might be managing state or state and one-shot actions.
Yes. In the case of
and now
Kubevela,
you.
Yes.
Now,
yeah.
I gave you as generic as possible without entering into which one is doing what.
So Kubevela is about managing your application specifically, not also infrastructure and all the other things. So Kubevela is application centric, and then the platform engineer or the ops persona creates abstractions and pipelines and stuff that then the developer persona can use. Does that seem right? It feels like you're not listening.
No. But I'm sure it's right. Sorry, I was focusing on the demo later. Yeah.
I want you to listen because I want verification. Yeah, and you tuned out.
It's correct.
It's application centric. It's about your application. And then we have Cradix. So Abby said about Cradix that the difference between Cradix and Crossplane is the abstractions that Cradix provides to help you build platform are not only easy for your developers to consume, but they're easy for the experts to create too. So it's thinking about how to interface with both of those personas, as opposed to Crossplane is more flexible. There's more you can do, but there's a lot more complexity, except it provides a way to do an easy interface to the developer persona. Does that seem about so? Did that feel right? That's just based on our conversation last week.
If I say something, I'm going to offend friends that we have. So no, you continue.
I'm focused on summarizing what people said during our conversation last week.
My brain cannot look for mistakes on what people say. So
okay, so I see that there's a Cradix fan, Chris. Hello, Chris, and listening right
Chris.
now. So we love your opinion too. He said last week's vote was rigged, and he also said Cradix. So tell us how you really feel, Chris.
Let me tell you this. By design, it's Whitney who created the voting. And she's the only one who has access to voting.
What are you
to
talking
do mischief.
About?
So if it was
yes,
so if it was rigged, look at there's the person who rigged it.
I have no skin in this game. If anything, I would have chose Kubevela just to give Victor a hard time if I was choosing. I did literally vote for Kubevela. All right, so Victor, tell us about the one who won the vote. We're kind of implying, but who won the vote? Show us the screenshot.
Crossplane, of course.
I want the proof.
You want the proof? Here are the rigged. Here are the rigged results. And I suspect that Chris is going to demand recounting.
It was a very close vote right up until the very end. It was exciting. If you want to vote, in the description of this video is a link to the CNCF Slack. There's not going to be voting this week, but in general, if you join the You Choose channel on CNCF Slack, You can participate in our votes and be a part
You know-
of. Yeah.
That voting in our case takes 5 days, right? Is
We
that
leave
correct?
it open for 3 days.
5 days.
3
I said
days.
that's how votings in countries should be done as well. Kind of like you might have realized the mistake the first time you vote. Go there, change your vote. So basically,
Anyway.
there was bullying involved over there, I suspect.
I will say about our rigged system is that we do have it. Anyone can win, but we're only ever going to demo CNCF technologies, and we mostly feature only CNCF technologies as guests because we have to scope it somehow. So even if Cradix had one, since Cradix is not CNCF, Victor would still be demoing Crossplane or Kubevela today.
I mean, if Kubevela won, then it would be Kubevela, yeah.
Yeah. Org has a unrelated question, but building from scratch, would you try the one-shot action or GitOps first?
So depends what org tree means by Argo. There is argocd, there's Argo workflows. So if you're looking for synchronization or what people call GitOps, it's argocd or Flux. I personally think that Flux might be better done technically, but argocd is basically dominating them, so it's probably a safer bet and it has much more contributions, what's or not, so probably argocd. And Tecton would be for workflows, what people call CI, and there is Argo workflows for workflows.
Actions.
And GitHub Actions, yeah, and we're going to talk about it.
Next
Is it next week? Yeah, next week, yes.
All right, so let's see you demo Crossplane, the chosen technology.
Okay, bring the screen, Whitney. Okay,
right.
there we go. Okay, I'm going to start by executing something without showing what that something is, mainly so that something is running in the background while I show you what. So I went crazy here. Let's start with that. And I created for both Kubevela and Crossplane in this case, everything required to do everything related to application from scratch. So create a repository with some minimal files, deploy an app and add source code of the app and workflows and whatever is needed for the app apart from running in Kubernetes, add it to that Git repository. That's step number 2. And step number 3, connect it to a database, right? So 3 steps. First step, repository. Now, since this is Crossplane, you chose it. I have compositions. People create claims, which is a way how to claim those compositions, and compositions expand into all the resources needed. Now, I call this GitHub claim, right? It's up to you to define, and I keep everything simple. You want to claim a GitHub repo? Cool. It should be public, yes or no? And what is the language you want that repo to be written in? Or what is the language of the future application, which we don't have? Go, right? Cool. So, and that's what I executed a moment ago. Now I'm committing a cardinal sin, and I executed kube control apply. You should be doing GitOps instead, but since we didn't cover GitOps, that comes later. Now, this is what happens in the background when I executed that claim. Basically, it created a bunch of it created a repository in GitHub. Here it is. It created a branch. It pushed some files to that branch, and it created a pull request just for somebody human to confirm whether that's all working as expected. Cool. So I got the repo with everything I need there to start working on Go applications, and I'm going to clone that repo. I'm going to go to that repo. There we go. And if I take a look at list of pull requests in that newly created repo, you can see that there is a pull request called initial created 1 minute ago. Cool. So it did what it needs to do. GHPR view init and JSON files. So we can take a look at what is in that PR. I don't like web UI, so you're watching everything from a terminal. It created the README. It created, since we chose Go, it created Go mod, Go sum, main Go file. Basically, this is the hello world source code that people can use now to work on their application. Cool. Now let's merge that pull request. Init, this is PR merge. Called init, that's the name of the PR, and rebase. So I merged it to the main line, and if I pull, we can see that now I have those files in the main line. Cool. And if you look at this one example, this is the example source code of the future application. People can now start doing whatever they need to do on that application. That's up to developers now. Now, that's source code. Now let's talk about the application itself, right? I'm going to create a new directory, apps, in this new repository. So this repository is completely new. I'm going to copy file that I prepared before, AWS SQL YAML. I'm going to copy it to that directory, silly-demo-db.yaml. There we go. I'm going to copy one more. I'll show you what those files are, so no worries about that. And this is silly-demo-db, let's call it password.yaml, right? I just saved myself from writing it from scratch. Not that it's difficult to write it from scratch, but there we go, right? And before I show you, I'm going to apply those two files just so that it's running in the background. What did I do now? Okay. Do I have this file? No, I don't. Which file do I have? silly-demo-db. Okay. Let's rename this. Move.
It says
okay.
APSS word.
Yeah. Somebody doesn't know how to type when microphone is shoved into his face. Let's see whether it works now. They make... Okay, one is working. Okay, cool. Now, what did I create? One is stupid because I was too lazy to set up external secrets so that passwords are fetched from somewhere. So I'm just giving a secret for the database. Ignore me. People should be fired for doing this. Now, the important one is still here, Crossplane claim, just as before. This time it's called SQL claim. I actually mixed the order. We're going to do the database first. And I'm here saying I want to create something that Victor defined as new API endpoint, SQL claim, cool. This is how I'm going to name it, cool. I want the database, and now these are the options provided to me by whomever designed this service for the platform. I want my database to be in AWS and be Postgres. This is the version. I want it small because I have no idea what sizes are available in AWS. I want this region, and I want that SQL server or Postgres server to have two databases, DB01, DB02. Easy, right? So now if you take a look at what's happening in a cluster, you can see that Crossplane expanded this into a bunch of other things, right? It created some internet gateway. Let me do this. It created some internet gateway, route tables, security groups, subnets, silly things that you need in AWS. But it also created, it will create a secret with the full authentication to the database. Later, it's not working yet. It will create databases in that server. Once they're created, it creates subnet group and, most importantly, instance. This is RDS itself. And I just realized that, okay, so 1602 is not supported anymore. I need to modify this. Okay, Vim. Which versions are supported now, Whitney? Tell me.
16.3.
Well, why are you here? Console. AWS. I don't know. I need to check now. This is going. Oh, I need to log in first. This is going to. I'm doing it in a. Entertain the guest, Whitney, while I figure out.
So what you created an empty repository, and now you put some files in that repository.
Yes.
One that gave you a password where you just wrote the password in the file, and then you did the SQL claim, and then that's expanding into a lot of other resources.
Yes.
And all those other resources it's expanding to are filling up this once empty repository that you just created.
Yes.
Okay.
Yes, exactly. I mean, I'm saying yes. I'm not listening to you. I'm trying to figure out the version, but I'm sure that what you said is correct.
I'm not at all, so I don't know.
Whitney, you know with whom you're working. Come on. 16.3. Okay, this was easy. 16.3.
That's what I said.
Well, I wasn't listening, so I cannot confirm. Okay. Cool. Where were we? Let me see. Okay, StreamYard back. Cool. Now the database will eventually work, or it will not. Nobody knows. Let's try again. Whether it recuperates. Okay, look at it. It's creating it. Now it doesn't complain about being a wrong version. And I will need to update the repo. Cool. Now, where was I? SQL claim, blah, blah, blah. Okay, now, now let's do, let's copy another file. This is now the third and the last part. And I'm going to apply it again. There we go. And now when it's running, I'm going to show you what. So we need application itself as well. Now this is the third claim, up claim. Again, designed by whomever. This is completely up to you to decide how the schema looks like. In this case, I want it to run in production. I want to use this image. I want tag to be fix me because I don't know what tag to put there yet. We haven't built any images. We'll get to that later. This is the port, this is the host, and so on and so forth, right? And I want it to be connected to the database using the secret that will eventually be created. And I want this application to be connected to the repository we created earlier so that whatever is required for this specific app to be there should be pushed there as well. And I want to enable CI. But the tool is none because we haven't selected any CI tool yet or workflows. Cool. Now, if I take a look at this, this is now what Crossplane created or is creating, right? It will soon be fully operational. A few of the files, but what matters is that it created a bunch of objects. That's a Crossplane way to say create some Kubernetes resources like deployment, ingress, service. Cool. It created a new branch in that repo with some additional files we're going to check soon. It created a pull request, and it created a dev box and Docker file and .nu files. Basically, it created the files that are required for this application to run as one-shot actions, CI, that we're going to choose later. And eventually, this will all be available sooner or later. Hopefully sooner. Okay, one more missing. Already there. There we go. It's all there, right? And now, if I do kube control dash namespace, I set production. So let's check what's happening in production. Get all the resources and ingresses. And there we go. It's all working except the pod. Pod is failing. And it's failing because we haven't built an image yet, right? Not a single one. So basically, from the Kubernetes perspective, everything was defined. There is a service, there is deployment, blah, 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 blah. But we haven't built the image, and that's we haven't done that because, you need to wait until the next episode to figure that part out.
I have 2 questions.
Okay, go for it.
What's in the new repo now?
Okay.
The files?
Great question, because that's just what I started typing.
Oh.
We are synchronized. Excellent. So it created a pull request. There's a pull request. And if we view silly demo CI, and I want to output it as JSON files, it created Docker file, right? So that it can be built eventually, right? It created debug CI JSON. This is debug how I prefer to download dependencies. And created a .nu. This is a script, new shell. I like to script in new shell that contains all the commands required to build stuff and do stuff. And actually, I can show you the new shell in a second. But first, let me.
Didn't create any. There's no Crossplane files in the new repo. Crossplane's like your.
No, I already created them in the apps directory. It cannot create itself, right? So
Yeah.
I already did those. Here they are, right?
Okay.
So you define those because that defines everything, including how.
Where's the app directory on your local, like on your EKS cluster that you're managing all of this with?
No, apps directory is on my disk on my laptop, and it's a clone of the repo that we created first.
Okay.
So I'm doing that inside of the local copy of the repo we created.
Okay.
So if I merge this and I pull the latest, I should get those files. And for example, and this is just example, .nu, right? So here is already a script that, hey, this is how you update claim with new releases in the future. This is, you just execute this to build an image. No need to worry about it. You execute this to run tests. And you execute this that combines all that to run CI. So in the future, when we decide which tool we're going to use for CI, for workflows, all we have to do is to, let's say we choose whichever. I'm going to say Jenkins just because it's not one of the choices. All you would have to tell Jenkins is, hey, execute the command run CI. That's all you have to do. It's all there already, right? Okay. So far, so good.
A second question.
Yeah, as many as you want.
You showed us a couple Crossplane claims. And I want to know, I want to see what's happening behind those claims. Like how you, at least for one of them, how you put in.
Like what it does or how how I defined it?
How a platform engineer is creating a Crossplane claim.
Sure. GH repo view Crossplane SQL, let's say, web. Now we can do this the easy way or the hard way, depending on how freaky you want us to get. But basically, I do everything using KCL. And that case, I don't know what KCL stands for. C is configuration, and L is probably language, and K is Korea. I don't know. It's not Kubernetes specific, so it's not Kubernetes.
Okay.
I don't know what is it. Korea. Why not? So basically, this is the SQL for the database. And now ignore the weird syntax KCL, but basically I'm saying, hey, you know what? If somebody chooses to create it in Google, then create a database instance in Google, and those are all the parameters that are configured through the inputs from the users. Create a user in that database server, create some Kubernetes resource object, in this case, user from the SQL provider, and do a bunch of silly things And once you're finished with Google, if somebody chooses, and then some common things like, what is here? Let me see. Create a provider config that will instruct Crossplane how to use the database. Create some secret and create a database itself inside of that server, and create some additional Kubernetes resources like external secrets, and so on and so forth. Now this I can scroll probably.
I'm looking at the scroll bar on the right hand side. You're not even halfway down.
Yeah, a lot, because these are many permutations, and all of them multiplied by a factor of 3 for Google, AWS, and Azure. Maybe more, I'm not sure. Anyways, and I'm using KCL. You could do it in YAML, you can do it in Python, you can do it in many, many different ways. But the point is that you define what Crossplane should compose when somebody creates a claim. You create a claim, I take input data from that claim, and use that input data to decide what to do and when to do it and how to do it and so on and so forth. Does that answer your question, or I can talk more about it?
It answers my question. If any of y'all have questions, feel free to ask them and we'll answer them live.
Cool.
So that's it. The API layer has been added to our,
Yeah, but I'm going to delete now everything because this is all horrible, right? We shouldn't be applying resources with kube control. We should use other tools for that. And we shouldn't be allowed to apply resources before we set up some policies that will decide whether it's okay or not okay, right? So 2 out of many other terrible mistakes. We're done.
We're done.
And I'm going to add all the changes, commit -m something, and I'm going to push that. And now we're finished with state management, which somehow works but needs additional tools, and somehow doesn't work because there is no image deployed. So everything is working except the application itself.
Right on. So we need to talk today about policy and about state synchronization.
Yeah. You remember what I asked you before we started the show?
No.
I told you actually, this can last anything between half an hour and 3 hours.
Yeah. And I was like, it'll be under an hour for sure. And that's not.
I went for half an hour with my kind of 2 seconds explanations, but it's all your fault now.
Yeah, I'm asking too many questions. We have a helpful statement that the K for KCL is Fusion.
Okay, those are Fusion folks, yeah. Very interesting. I think that we're going to have one of the Fusion projects.
Well, they're not writing me back, so I don't know.
Maybe.
If you're out there listening and you know Fusion or Fusion Stack and you want to be a guest, DM me on the CNCF Slack. So let's talk about. Well, can I say something about policy? I hate that people just say policy, because it was security. There's like policy. There's like cluster level policy, which is also called admission policy. There's network policy. There's like mutual authentication policy. There's like policies all over the place.
Yeah, and we can do all of them in the next episode within 8 to 17 hours, or we can stick to admission controller policies.
So we're going to talk about admission controller policy. Do you think a platform, an internal developer platform, needs to consider all of the different types of policies?
Yeah, you need to be able to say what is okay and what is not okay. And many people would approach that from security perspective. I don't like that because that somehow alludes that you're acting as a policeman. I'm going to catch you if you're doing something you shouldn't. I think it's very valuable for educational purposes, right? So if I could have defined policies, for example, and probably should have, that say, you're free to specify any RDS version, but actually those are only those are okay. right? So ideally, with the policy, the error that I made earlier should have been rejected at the API level, should never have reached even insides of Kubernetes.
So Otto May properly says, if I don't want word abbreviations or overloaded terms, maybe computing isn't the best.
Yeah, also, if we don't use abbreviations and overloaded terms and stuff like that, then our value on the market drops and we get lower salaries.
Exactly.
So I definitely don't want to do that. If anything, I will be, starting from the next episode, I will be inventing my own abbreviations that nobody ever heard before. Wait for it, you'll see.
Just so we can be the one to teach them in the end.
Yeah.
All right. So why do we need cluster level policy? What's it do? Or admission control
Basically,
policy?
you want your API to reject things that are incorrect rather than accepting them and start working on something, and then nobody knows whether it's okay or not okay, right?
Yeah.
It's, among other things, it's safer on one hand, but it also gives better user experience. When I did kube control apply, if it told me right away you shouldn't do this, then I would know instead of hoping that it worked and discovering later that it doesn't.
Yeah.
Right? So it's good for both security and user experience.
So helpful messages that that teach you.
Just to be clear, there are already policy-like stuff is already in a cluster because I defined schema for those resources. So if I put a field now something, it would be rejected right away because it doesn't match the schema.
Okay.
Right? If I put a string in as a value of a field that is only integer, it would also reject it automatically. Kubernetes does that out of the box. But there are cases like, hey, versions are a string. It can be anything. I need additional policy to validate that.
It's good for governance and compliance too. Like if you have organization-specific rules that you need to uphold, cluster level policy is good for that. And probably also cost optimization or things related to cost to make sure people aren't making egregious too big requests that get made in the cluster. So what differentiates Kyverno? Why from all the other tools that do this would be API Gatekeeper, Cloud Custodian, validating admission policy. Keyboarding.
Yes, I don't have a stake in this one, unlike what we spoke so far. So my opinion, Kyverno is Kubernetes native, meaning it was born in Kubernetes. It was made to work well in Kubernetes. While OPA with Gatekeeper, OPA is not really that, and then Gatekeeper was made to somehow make it work in Kubernetes, and I'm not very fond of the syntax of OPA. On the other hand, to be clear, I'm not very fond of YAML either. So I'm just discovering that maybe I don't like Kyverno either. But anyway, I think it's the most commonly used project. It's basically the safest bet.
It's Kubernetes native. When OPA Gatekeeper, you use Rego. I think it, but both, in terms of those two projects, they both have been around long enough, and they're both graduated. I believe that they both have expanded, that they've converged.
Yeah, they're both great.
You can't go wrong. Yeah.
And then we have Kubernetes validating admission policy, which is now part of Kubernetes. So you have admission controllers, and soon you will have mutations already running inside your cluster since not long ago. So you might not need any additional tools, right? And it's great, but not as powerful as Kyverno. So I would start with those baked into Kubernetes and say, it's already there, why not, right? And if I reach a limit, I would then switch to Kyverno. And here's the good news. Kyverno in the past was some kind of JSON YAML combination, something relatively weird but cool for the syntax. And now, Kubernetes validating admission policy is YAML, but values are cell.
Common expression language.
Common expression language. There we go. Yeah. And Kyverno since then, or in parallel, added support for cell. So if you want to switch to Kyverno at some later date, most of the things will just work, right? I actually, when I was preparing all the paths in the repo for all the tools, I actually wrote Kubernetes admission first, and then I turned to write the same or equivalent policies in Kyverno, and I wrote a different YAML, but all the values, which is where most of the work is, the validations themselves. So I just literally copied and pasted them. So they're easy to switch from and to.
Back when we did the policies episode a long, long time ago now, I don't think validating admission policy was GA'd yet. So
no, it wasn't GA'd, so it wasn't part of Kubernetes. You would have to enable it specifically, and in some cases you couldn't even enable if your provider doesn't allow you to do that.
So now it's the real deal. So let's see Kyverno in action. What are we going to create policies around for?
Okay, let's do it, yeah. Okay, so I installed Kyverno while we were talking, and I'm going to do the same thing as before. I'm going to apply it first, and then I'm going to show you what I did. Here we go. So this is a policy, actually two policies, I believe. Cluster level policy, it applies to more or less everything. And one is called scaling enabled. And that policy will be applied only on resources called upclaim. That's one of the three that I created before. And only if I create or update, I don't want policies to delete. And basically what it does, and this is now not the original Kyverno syntax, but cell itself. Basically, I'm saying, hey, it needs to have scaling field specified. And that scaling field has to have enabled field as well. And that field enabled needs to be true. So if those things are matched, if you have scaling enabled field set to true, you're fine. Otherwise, there will be trouble. And the second one that says you need to have a scaling field specified as well. And the value of that field, value of the subfield min needs to be greater than 1. So you need to enable scaling, and you need to say that at least 2 replicas of the application needs to be set. It can be more, it cannot be less.
So
Make sense?
Is a validating policy. It would be possible to make a mutating policy that could change objects and add the scaling and add at least 1.
Yes, I am. This is where I'm in conflict with many people. I don't like it.
Yeah, I'm baiting you.
And we don't do things I don't like.
Why don't you like it?
Because for third parties, I think it's perfectly fine. Like Istio will mutate your resources, right?
To add a policy.
For your resources, no, because if I mutated application, so let's say that I'm going to stick with this example. If I mutated this resource automatically to enable scaling, first of all, how would I educate people that scaling matters?
Yeah.
Right? They would be all oblivious and they would keep making the same mistakes, right?
Yep.
So I like the I don't like the removal of education in case of mutations. Second, I can mutate it. So I could create a mutation that if minimum number of replicas is not specified, set it to 2. And if it's specified, keep whatever it is. But then the result of that would be that it would never be specified. Because people would not even know that it exists.
Yeah. That falls under the education category, doesn't it?
Yeah, exactly. Exactly. So I don't like it. I'm sorry, Kyverno folks and everybody else. I don't like it.
What about, do you think it matters that it's declarative? When you're
It's in a cluster. Nobody knows what's in a cluster.
Okay.
Right? It's there. It's in a cluster. Who knows? Nobody knows.
All right.
Okay? Okay. Let's try to apply the same manifest of the application we applied before. The one I deleted at the end. Same one. No changes.
Okay. All right.
You cannot do it.
No.
You never set enabled. Right?
Yeah.
Now, since I'm freak about commands, I'm going to change that file and I'm going to add scaling enabled set to true. Right? Okay? Mm-hmm. Cool. Done. We apply it again. So, okay, you're doing better. You enabled scaling, but you forgot to set the minim field to be something greater than 1. Right? And then I changed that as well. Poof. Right now my app looks like this. Right? We have this now here. Cool. Let's apply it again. Here we go. Now it works. And now I'm going to go there and push everything back to Git just to keep it for later. And I'm going to show you kube control, namespace, production, get pods. It's still not working. Right? There is still no image.
Still no image. Yeah.
Still no image. And
that's not happening today, though.
Yeah, yeah. I mean, this is such a disaster, Whitney. Cool. We're finished with that.
People say your platform capability should be secure by default, or that they should have guardrails. This is part of what they mean.
Part, not all, but yeah, part it is. Yeah.
What else could they mean when they say that?
I mean, secure can be is infinite pit. You know, like it's like black hole. You fall into it and there is no time stops. Kind of like literally the time stops. Kind of there is no time. It's infinite from there on.
Yeah. Okay. So everything. So it's impossible.
Everything.
Don't even try.
and look, and if you're in consulting business, that's so valuable. Kind of like you will need me forever because it's everything. And then it changes. So it's everything and it changes all the time. So even if you ever reach the limit of infinity, it will move by then.
So it's in our educators' best interest to have overloaded terms and a lot of acronyms so that we can always teach forever.
And to always say everything is wrong.
And then consultants keeping security deep and complex and touching every surface. Let's talk about GitOps now. First of all, I guess, what is GitOps?
GitOps has 4 principles, and I might not remember them all, and I'm going to paraphrase it.
Is that resources have to be defined declaratively. That's the first one. Yeah.
Yes. I think that one is silly, but okay.
The second one is that they should be versioned. Yeah.
Yes. Mm-hmm. That's Git, essentially.
Yeah, that's going to be done with Git. I don't know of any exceptions. There's probably exceptions. The third one...
You never worked in a bank, Whitney.
That's true.
They still run on SVN and CVS. CSV, sorry.
The third one is that the resources are pulled automatically from usually a Git.
That security part.
And into your cluster. And then so that's usually the GitOps tool, like argocd is doing that. And then the fourth one is that the desired state is continuously reconciled with the actual state. Yeah.
Exactly.
That's your Kubernetes doing that. Yeah. And that's GitOps. And why?
And I see Alexi saying Flux. Flux is awesome, but I'm not sure that it will be able to keep up. But it's awesome. I love it. Kudos. It's better designed. Okay, go on, Whitney.
So why is GitOps an important part of an internal developer platform?
Because quite a few things, right? First, it's safer because we can lock our clusters and say nobody has direct access, maybe read access, but not write access, period, right? Kind of, that's it. Second, we keep track of the desires, kind of like if people go and do random things in clusters, I have no idea what's going on, right? When something goes wrong, I don't know what you wanted to do. Kind of like, you ordered this thing, but waiter never wrote it down. Kind of, and we don't know what you got, and we don't know what you wanted, and who knows, right? It's a way to write down what you want. And store it in Git, because that's the only, not necessarily the good choice, but the only reasonable choice we have today.
And I guess it's the everybody uses it thing that your favorite reason, because everybody does it. In terms of using Git.
Until I change my mind about something, and then I say,
nobody
hey,
does
you're not
that.
going to do it only because everybody does it. Like, ask me about KCL versus Helm, and you'll hear a very different argument.
So basically, what you've said so far is using GitOps, it makes it so people aren't accessing the cluster directly. We're moving the threat boundary out to the Git repo. And also because we have a system of record of who's requesting what and why. And
And that continuous loop of, since I know what you want and I know what it actually is, I can work continuously to make sure that those two are always the same. Right? So you go there, you delete you do kube control delete namespace because you're a horrible person, and pay attention how I'm trying to avoid using words I normally use. And doesn't matter. argocd or Flux or whatever you're using are going to say, no, but that's not what you wanted. You told me that you want the namespace, and you told me that you want those things in the namespace. I'm going to recreate it so that horrible person can keep deleting them as much as he or she wants.
Yeah. All right. So we've covered GitOps. We've talked twice this episode now about argocd and Flux. There's not a lot of difference between them.
No.
And the people voted for argocd when we did the episode during chapter 2. And
yes.
So let's demo it now as part of our IDP. What's it got to do with an IDP specifically?
I mean, IDP is a collection, is a platform, right? And a platform is a collection of services. And services need somehow to be delivered to the platform. And GitOps happen to be given our choices for the platform to be the most convenient and the best way to deliver it. Now, there are many ways how we can do GitOps. So we need to push to Git. We know that much. But now I can push, whether in that platform, I'm going to push by writing YAML in my VS Code and push to Git, cool. Or I'm going to use some web UI, which we're going to see later as well in one of the sections. And in web UI, I'm going to fill in some fields and click a button. And that button can also push to Git, right? So kind of Git happens to be one, not necessarily the only way how we specify what we want. And argocd is making sure that that goes to Kubernetes API. And why? Really why? Because I actually chose which tools go to each category.
So, like, I kind of get, like, the threat. Is it, like, a good way to keep track, again, of what's happening?
Yeah. I mean, everything is in Git. You can keep track.
Yeah. Cool. So you've installed Argo. We can see Argo. Argo.
Yeah, here's Argo, and there is nothing in Argo. Right now, Argo is a version. Not by choice. And if I go to the cluster, there is nothing right now in production because while we were talking, I deleted the application that I applied. So what I'm going to do is that I'm going to apply this to the cluster, whatever that is. And what that is I'm going to show you. That's basically argocd application resource. Again, CRD, again, extending Kubernetes API. Hey, it basically says, watch what is in this repository, specifically watch what is in the head, in the main line of that, and the last commit of that repository, and inside of the directory apps. And whatever is there, synchronize it into the production namespace, and do all the good things, like do it automatically, right? Mm-hmm. And if I take a look at what is in the production namespace that was empty, there we go.
Da-da-da-da.
We got our stuff. It's all working except pods. Pods will never work. We will give up on them eventually. Or not. And that's it. And if you want to see something pretty colors, there's argocd. And there's what it did. Right?
Awesome.
There we go. All of them. Really, look at it. So many things are happening, Whitney. Okay.
And that's all from Crossplane resources
Yeah.
that we looked at earlier. Yeah.
Yes, same thing.
I see the
Basically,
subnet group and the VPC.
argocd did what I did with kube control apply before. In a nutshell.
Mm-hmm. So it's pretty cool if we just like step back and think, you can add something to Git. It creates the resources in the Kubernetes cluster that in turn create resources in AWS. It's beautiful. Chef's kiss.
It is.
Mm-hmm. I think that's a wrap, Victor. There's no voting today. So
No voting?
If you're watching this later and you have questions, feel free to ask them in the You Choose channel in the CNCF Slack workspace. There are links to find it in the description of this episode. And
You can also put them as comments. Then we can bring it on a screen.
Oh, if you're here live, yes. But,
Yeah. Or if you're not live.
Or if you're not live, you can also come.
Just we're not going to answer it on live, but you can try.
Join us there if you want to discuss stuff. And then next week, join us same time, and we're going to talk about the one-shot actions or the CI part and finally get that image built. We're not going to actually build it next week. We're going to just bring on guests to talk about it. And what do you want to say?
I mean, if this is the speed with which you work, my application is not working, we'll fix it next week. I don't think you deserve to work wherever you work.
We'll talk about fixing it next week.
Not even fix
it 2 weeks from now.
2 weeks from now. Excellent. Yeah. That's exactly what I was hoping for. Brilliant.
Next week, we're going to evaluate tools. We're going to talk about GitHub Actions, Argo workflows, and Tekton. So we'll have guests on again next week, much to Victor's dismay, to give us presentations about each. And that's a wrap. Thank you. See you next time.
Cheers, everyone.